All right, welcome back to pre-calculus. We've got some conversion problems. By that, I mean we're converting polar coordinates to rectangular or converting rectangular to polar. Okay, so you have to be kind of careful when you're reading this. I recommend drawing the picture first so that you make sure you're still getting the same point in the same area. Okay, so we are converting something that looks like it's a polar coordinate, 1 negative pi over 4, to rectangular coordinates. All right, so here we go. We go to negative pi over 4, which is down here somewhere. Okay, it's 45 degrees down there. And we're just going to take one step out. And we want this point right here. So when I get my x and my y, I better come up with something that looks like it's in quadrant number 4 in order to make sure that it's going to align with what's going to happen here. Now, converting to polar coordinates, I'm going to draw a little triangle here because that's kind of the trick for all of this stuff. So we know that we have an angle. So what I'm going to ask you is, we have a triangle where we know the hypotenuse is 1 and we know the angle. Can I convert this into the adjacent and opposite sides as I'm doing this? So sure. So if we look at what's going on here, we could say, okay, the adjacent sides, we have the cosine of an angle is equal to the adjacent over the hypotenuse. If I multiply both sides by the hypotenuse, we can say the hypotenuse times the cosine of the angle is equal to the adjacent side. That's exactly what I'm looking for. Okay, I'm going to go ahead and sum out the other side. So we could say sine of theta is equal to the opposite over the hypotenuse. Multiply both sides by the hypotenuse, so we have hypotenuse times sine of theta is equal to the opposite side. That's exactly what we're looking for down here. Okay, so that's what we're going to have down here. We're going to get this part. Okay, so that's kind of what we're doing with this thing. Okay, let's go ahead and get rid of this stuff. Okay, go back to a pen and go ahead and do this. So my x value is going to be hypotenuse times cosine of theta. My y value is going to be hypotenuse times sine of theta. So we could say x equals 1 times the cosine of negative pi over 4. Y equals 1 times sine of negative pi over 4. All right. Now, when I go to my calculator, I'm going to have to make sure that I'm in radian mode. So we could go back to mode and go down here and say radians, say enter. There we go. And we're going to have that going on. All right. So it's just 1. So it's 1. You don't have to type in the 1. Okay. Times the cosine. Don't forget the negative. Negative. Where's my pi? There it is. Negative pi divided by 4. The nice thing about the fancy calculators, even the not so fancy calculators like the TI 8384, the calculator knows which quadrant things are in. So it's going to put the right thing on here. Okay. So, hey, would you look at that? It was a positive number. Like just exactly what we knew because cosine is positive in the fourth quadrant. So I'm going to type out 0.707 because we have to 3 decimal places. Okay. And we're going to do the same thing with the signs. We could say 1 times sine of negative pi, there it is, divided by 4. Okay. And then go ahead and do that. And we ended up with a negative 0.707. So equals negative 0.707. So as I'm looking forward to where this point is, if I just had to graph the point x equals 0.707, y equals negative 0.707, I'm going to get a point that's going to look pretty much like that. So I'm pretty confident that my 0.707 and negative 0.707 is looking pretty good. I like this. Okay, so I'm going to say I feel comfortable with what happened here. Okay, for the next one, we're going to say this is negative 1, 4.95. So we'll go ahead and draw a little picture. Okay, negative 1. Oh, that's too big of a 1. And then 1, 2, 3, 4, 5, because 4.95 is almost 5. We're going to be up here somewhere. So this is the point that I want. Okay. So as I'm looking at my triangle here, we have to figure out this. We have our x and we have our y. Okay. Again, my x was negative 1, and we have 4.95. So here we have negative 1, 4.95. So from the two sides of the triangle, can we figure out the hypotenuse? I'm like, oh, sure we can. R is just going to be equal to negative 1 squared plus 4.95 squared, and then take the square root of these things. Okay, so we can go ahead and figure this thing out. So we're going to have clear U. So we have 1 squared is 1, plus 4.95. There we go, 4.95 squared equals, okay, and then we're going to take the square root of that sum, 25.5025. So second function square root, second function answer. Okay, and we end up with an answer of R is equal to 5.05. It's almost like somebody planned that, you think? Okay, the next thing we have to do is we have to get this angle, right? I need this theta. It's in the second quadrant. So here's why I did this way, because if we have theta is equal to, let's see, we have an opposite and adjacent. What kind of trigonometric function relates the opposite and the adjacent to the angle? And that's the tangent. So we're going to say that we have the tangent of theta must be equal, or we have the tangent of theta equals, okay, must be equal to 4.95 over -1, okay? Or we could say something clever like theta is equal to the inverse tangent of -4.95 over 1. Okay, now we know because we've worked with inverse trig functions a lot before that this is going to give me an angle in the fourth quadrant. Let's go ahead and check it out. So I'm going to go back here. I'm going to say mode, go back to degrees for just a moment here because I allowed you guys to do that. That's fine because degrees are more familiar and I think that's okay. Okay, so we want the inverse tangent, okay, of -4.95 divided by 1 is just going to be inverse tangent of -4.95 equals, and I got -78 point, what do we get here? -78.579 degrees. Okay, now where is this? -78.579 degrees is down here somewhere. Well, that's not where my point is. My point was up here. So what I'm going to have to do is I'm going to have to add 180 degrees to this in order to get the angle in the second quadrant. So we're going to say plus 180. Okay. And I get, okay, it's 101.421 degrees. So it's 101.421 degrees. So my answer for this thing is going to be r theta, so my polar coordinates, okay, is going to be 5.05 as my r, and then we have 101.421 degrees, 101.421 degrees, and that's my point converted from into polar coordinates, okay, in degrees, not in radians, but we could fix that if we had to. I didn't ask you to fix it. I said you can leave it in degrees because again, I think the familiarity helps more than the changing it off to radians. That day will come. It's just not today. Okay. And the next one is we have it's like it's -2, 3. And I'm going to double check this thing one more time. So we have to check 2 and 3, or -2, 3. And we have to change this to something. I think what we're changing this to is, let's go ahead and take a look at this. Back over here. All right, we're not looking at that yet. Okay, we're changing this to rectangular coordinates. So these are in polar coordinates. So -2, 3 is in polar coordinates. So it's a really important thing to look at because it doesn't look like this. We have to convert to rectangular. All right, I'm trying to trick you with this one. All right, so don't get fooled. So the first thing we have to do is we have to graph its direction first, so its angle. Like, where the heck is 3 radians? Like, well, it's close to pi radians, right? Pi radians would be 3.14. This is 3, so it's over here somewhere. Okay. So I'm going to be looking over here for my radian, my angle of 3, but we have to walk backwards because it's -2, 3. So I'm actually going to walk over here somewhere, and I want a point that's over here. I want this point right here. All right, so we have our hypotenuse and we have our angle. We have to change this to the adjacent side and the opposite side of this triangle right here. Okay, if I'm looking at this triangle like this, we want this part and this part as far as my triangle goes. Okay, we got rid of the whole thing, didn't we? So as far as my triangle goes, the highlighted part of my triangle, that's what I want to go deal with. Knowing I have a hypotenuse, which is -2, I had to walk backwards, but this length is still 2, and my angle was 3. Okay, So let's just go ahead and see what's going to happen here. So just like we did with the time before, as we said, okay, the adjacent is going to be, we have -2 times the cosine of 3. It's in radians. This will be my x value. My y value is going to be -2 times sine of 3. And we're just going to see what that turns up so we can kind of see if we got the right thing, if it looks right for us. Okay. Let me move me. So I lost my calculator somewhere. Here we are. There's the calculator. So let's go back to mode. We're going to go back to radians because we don't want to do this in degrees. We need to do this in radians. Okay. That's a place where people do mess up. Okay. So we're back to radians. I'm going to quit out of this. So I'm going to say we have -2 times cosine of 3. And let's see what happens. Okay. So I ended up with a 1.9, we'll call it 1.98. Okay, so my x value is 1.98. My y value, I'm going to say the same thing, -2 times sine of 3 equals. Did you have to graph it? No. Do I feel better because I can check it? Yes. This is -0.282, -0.282. So if I had to graph the point x equals 1.98 and y equals -0.282, I'm going to get 1, 2, 3-ish or 1, 2-ish over here, -0.2, -0.3, going down a little bit. I'm getting a point that looks like it's in the same place that my polar coordinate was. I feel pretty happy about my 1.98 comma -0.282 in rectangular coordinates in order to show that this is what's going on. Okay, so that's the 3 points I have to do conversions between polar to rectangular, rectangular to polar. If you get lost with it, please draw yourself that triangle. We've been practicing all semester about what sine means, what cosine means, how to get the hypotenuse from two sides of a triangle. I have every confidence that if you draw the picture, you go ahead and go through the process, you're going to get the right answer with these things, okay? So thank you very much for watching the video, and I will see you on the next one.